Now let's talk about congruence of triangle. We just talked about congruence of line segment, congruence of angles. Now let's talk about congruence of triangle. So here it is given that two triangles are congruent if they are copies of each other and when superposed they cover each other exactly. And why do they do so? Because their measurements are same. And why the measurements are same? Because they are copy of each other. Simple. So we can say here that look at these two figures ABC and PQR. This triangle ABC and PQR. They have same size and shape. So naturally they are congruent. So how can we write this? We can write it like this, that triangle ABC is congruent to triangle PQR. Now what does this mean? It means that if I pick up this triangle PQR and if I superpose on this, where would this P come? It would come in place of A. What about Q? It will come on place of B. And what about R? It will come in place of C. And they will superposed on each other exactly. So when you place PQR on ABC, P falls on A, Q falls on B, and R falls on C. Now, this we just talked about the vertices. What about the line segments? That is sides. So, PQ will fall on AB, QR will fall on BC, and PR falls on AC. So here PQ. Alright? This is called correspondence. Means two triangles are congruent, then their corresponding parts, be it angles or sides, they match one another. Okay? So, if we say this triangle, what are the corresponding part? Vertices, sides and angles. So, all the vertices, sides and angles of this triangle should match with this triangle. That is, vertices, sides and angles of ABC should match with vertices, angles and sides of PQR. So corresponding vertices will be AP, BQ and CR. Corresponding sides will be ABPQ, BCQR and ACPR. Similarly, corresponding angles would be angle A with P, angle B with Q and angle C with R. So, we can say that while talking about congruence of triangle, not only the measures of the angles and length of the sides matter, but also the matching of vertices matter. Means, I can't say here that AB is congruent to RQP. No, I can't say that. If I say ABC, I have to read PQR. Alright? Because these are the corresponding vertices and angles and sides. So it is very important to understand that how the angles or how the triangles are corresponding to each other. Because sometimes they are not placed proper way. So we need to rotate them in such a way that we can place them over the other in such a way that they can match. And that is where this corresponding concept is coming. Alright? So, this is the sign of corresponding. So, A is corresponding to P, B is corresponding to Q, C is corresponding to R. So, we can say that ABC is corresponding to PQR. Like that. Now, see, there are sometimes what happens that triangles are not properly placed. For example, here, if you look at this figure, this is your ABC and this is your PQR. Now, they are not placed properly. So, I need to rotate this to make them corresponding. So, I'll just need to rotate it. And once I rotate it, it will become PQR. Now this is same. See, now these two triangles are same. Before, it was not same. So you need to rotate the triangle and then see the corresponding angles and corresponding vertices and corresponding sides. Now, if I just keep it like this, they are not making sense. Even if I want to read like A is with P, B with Q, and C with R. And this is the reason I need to rotate the figure and then I need to see whether they are corresponding or not, or whether they are congruent or not. Now they are congruent to each other. So their sides and their angles and their vertices are corresponding paths. So in correspondence, it's not always necessary that you will be given the same shape and size in the same order. Sometimes the shape might be different. However, they are corresponding to each other, but the shape might be different, differently placed. So in that case, you need to move that, or you need to rotate that figure in such a way that they become congruent to each other, so that your corresponding parts would make sense. In this example, it is given ABC, PQR are congruent under the correspondence ABC, RQP. However, they have given here the name of the triangle like ABC and PQR, but the corresponding parts are given like this. That is, A is corresponding to R, B is corresponding to Q, and C is corresponding to P. So, this A is corresponding to R, B is corresponding to Q, and C is corresponding to P. Means, if I rotate this triangle like this, R would come here. I'll just write it next to A. Alright? Q would come here and P would come here. Now I can easily say that write the parts of the ABC that corresponds to PQ. Now PQ means CB. Angle Q means angle B. And line segment RP means this line segment means actually AC. So if I just write like this, it becomes very easy for us to understand the corresponding parts and write down it. So line segment PQ. When they say PQ, you have to read CB in this direction itself. Don't even change the direction. When they say angle Q, you have to write angle B. And when they say RP means in this direction, you have to read. So naturally, you will write AC because that's how you can read it, AC. This is what corresponding triangle is all about.